Today's video is designed specifically to help you with this worksheet, the Did You Hear About worksheet. We're in the middle of sections 9.4 and 9.5. We're solving polynomial equations by factoring and using all the tools that we've learned so far to solve problems just like these. And these are important ones in terms of application for what we're doing. We're going to run into these area problems quite often. So I thought I'd give a little help just with today, this worksheet in particular. On this worksheet, I'm just going to go through certain problems here to help out. I'm not going to do them all. I think a good one to start with here is going to be letter A right off the bat. It said the length of a rectangle is 3 more than the width. And the area is 70 centimeters squared. So find the dimensions of this rectangle. Whenever you're starting a problem like this and it talks about area and it talks about, again, kind of a real world problem like this that we're trying to figure out, I think it's a good idea to draw a picture if they don't already give one to you. So we're talking about a rectangle. So I just draw a rectangle and then we'll fill in some of the information that we need, that we have. So for example, it tells us that the area is 70 centimeters squared. So I'm just going to put that in here. We know how to find the area of a rectangle. It's length times width. And in this case, I don't know those yet here, but I'll maybe just put in L and I'll put in W just to kind of put those in there. And then I'll look at what it says about them to maybe help make an expression for one of them. It says the length of a rectangle is 3 more than the width. So I'm going to use that and make just a little equation even right below here. So the length of a rectangle is 3 more than the width. Well, that makes me think that I'm taking the width and I'm adding 3 to it. It's 3 more than the width. That's what my little equation here is saying. Now, why this is helpful is because we know, just like substitution with systems. This is a big help now. The length is equal to this little expression. So I can substitute that in place of the L here that's sitting here in this problem, in my picture. I know the length is the same as what I'm about to write. It's the same as the width plus 3. That's what the length is equal to. So I can use that now, and now I've cut this down where I just have one variable involved, and so now I can probably do something where I can solve it and figure out what that area is. So bringing it down here, just give myself a little more room. I multiply the length times the width to find the area of a rectangle, so it'd be W times W plus 3. And that is all supposed to equal 70, as they've told me. Good. Now I've got a problem here where, again, it's something where I can maybe do some distributing on this side. And then I got to get it all solved for 0 as well. So I got to move this 70 over to the left side. I'm going to have to subtract it over. I'm going to kind of do all that in one step here. So I'm going to do the distributing first. W times W would be W squared. W times 3 would be 3W. And then when I subtract the 70 over this side, it's going to be minus 70 on the left. And that is going to get me set up for factoring now. So now I've got everything equal to 0, which is what I want. And I've got everything as just individual monomials over here, a trinomial total. But now I've got it all set up with just those terms. So now I can get to my factoring. Remember, the first way to look to factor is, can you take something out of each one of the terms? And nope, I don't think I can take out a W or any number. So now I'm just going to look to factor into 2 binomials if possible. And it looks like this is W squared here, so I can bring that down to this is W and W here. And then I need factors of 70, and my sign, since it's negative 70, my sign's going to be plus and minus. And just kind of pulling off to the side here, factors of 70, I'll just kind of jump to the ones I need, 1 and 70, 2 and 35. I think I could do 5 and 14, but I'm just going to jump right to 7 and 10, and I think those are the ones that I'm going to need this time. Positive 10 and minus 7 for what I have my binomial, so W plus 10, W minus 7. I think that's going to be the trick. So W can equal negative 10 and 7 for the answers. And I'll realize, again, this is a problem with some context. We're talking about area of some rectangle. It's a real rectangle. So negative dimension isn't going to work. So 7 is going to be my answer. Again, sometimes you will have both answers will make sense. Or sometimes even none of the answers will make sense. In this case, it is just the one. 7 is going to be the answer for my width. Remember, I realized I solved for W. So W, that's why I labeled it like that. So 7 is the width. And the length was 3 more than that, so it's a 7 by 10 rectangle. When you're doing these worksheets, do you have to do and at least check the answers over here, even if you're not doing all the problems? Like, yes, of course you do. Or if you're doing all the problems, like, yes, check and make sure that you found the answer so you know, like, yep, I found something that makes sense and it's right, and it shows me that it's a possible answer. Okay, let's look at another problem then. I'm going to jump to letter D now. This time it says, this one talks about a square. So, right away I'm just going to draw my picture here, and then I'll start filling in information that they give me. Good enough for a square, you get the idea? It says if the sides of a square are increased by 3 meters, then the area becomes 64 meters squared. So find the length of a side of the original square. Okay, well, the original square, both the shapes I'm going to be dealing with are squares, as you're going to see here, as you can figure out, because I've got a square, okay, it means the sides are the same, and then both sides are increased by 3. So then I'm still going to have another square. It's just that this side is going to be 3, so x plus 3. And this side is going to be 3x plus 3. Both the x's, these x's stand for, I could make like a picture here of the original square, which should be a little bit smaller. This would be x and x, right? This is a square with the same side lengths. Well then, if I add 3 to each side though, now I'm getting the new square. And that's why each side length is x plus 3 and x plus 3. And that's the one they're talking about up here. And it says the area becomes, so we're saying like the new square. When I do that, the area becomes 64 meters squared. So what was the length of one of the original sides, which again is x, which is here, and it's in my problem. So if I solve this for x, I'm finding the length of one of the original sides. That's what x is, the way I've set it up. All right, so we know how to find the area of a square as well. Again, it's length times width again, so I'm going to multiply, in this case, the same binomial times itself. Let me write it down, though, first. X plus 3 times x plus 3, and that's going to equal the area of this new square that we've made, which is 64. Okay, again, right now I don't have, as I look for this problem, can I start factoring and solving and all that? Well, no, I don't have it solved for 0, and nope, I've got a couple binomials over here. You might think that it's in factored form, but it's not, because it's not have 0 on the right side. 64 is over here. I'm going to have to combine that 64 with whatever I get on this side when it comes to my constant. So no, I do have to definitely FOIL or use table method and multiply this side out. This side out, and figure that out, and then move the 64 over. Just because I don't do it often enough here, I'll use table method this time. Again, FOIL method works just fine, but just remember, here's a way to multiply these together. So x plus 3 times x plus 3, I'll get x squared for the top left corner, 3x for the top right, 3x for the bottom left, and 9 for the bottom right. And then when I combine the like terms here, I will end up with x squared plus 6x plus 9. And all that equals 64. And again, now you kind of see why I do have to multiply this out first, because now, then I got to move my 64 over and get it set equal to 0. But it's going to make a difference, obviously, when I take 9 minus 64 to help me use whatever factors I'm supposed to have on the left side. I need to combine those constants. 6x minus, 55, equals 0. Okay, good. So now I'm set up to start factoring. I don't think I can take out an x out of everything because there isn't one. I can't take out a number for this one either because there's no number in front. So I got to start factoring my two binomials. So x and x, they're going to start off with. I'm trying to find factors, again, of negative 55. So that tells me my signs are plus and minus. And when I do factors of 55, 1 and 55, I don't think so. 5 and 11. Yep, those are 6 apart. I'm trying to get to something that's 6 apart, so that makes sense to me. Plus 11 minus 5. So there are my two binomials, x plus 11, x minus 5. And so my solutions are negative 11 and positive 5. Negative 11 can't be the dimension for the square, so 5 must have been the dimension for the original square. And when I go up there and look for 5, yep, there it is, 5. That was the original side length of the square, which is what they were asking us. So yes, 5 is the answer. Okay, I'm going to do one more of the problems here for this video, at least from this worksheet. I'll also do another type of area problem too. But let me look at letter F now. It says the dimensions of a rectangular garden were 4 by 5 meters. So again, I'm just going to come over to some spare space that I have over here. And I'm going to draw another rectangle, and this one it tells me what the dimensions of this rectangle are. It's a 4 by 5, and I can put meters in there, but I'll just leave it for now. So it's 4 by 5. Each dimension was increased by the same amount. So they're going to increase each dimension. And what they're doing is they're adding this distance on here, okay, which you can think of as like, let's call it x, right, because it didn't tell us the amount. And then I'm going to increase the same amount over here, x as well. Okay, so far so good. The garden then had an area of 56 meters squared. So it's saying this new rectangle that we've made right here with the extensions on, okay, that's going to be 56 total for the area. Maybe you can kind of start to see, I'm just going to draw it a little better here, a little picky, but there, okay. So maybe you can see the big rectangle now that we made, okay, the original one had a dimension of 20, area of 20, I should say, and now the area of the newest one there is 56. So what's it asking for? Find the dimensions of the new garden. Okay, we're obviously going to have to find out x to do that. The area of, now again, the big garden here, as it gives us, is 56 meters squared. So taking a look at this length and width, well, here's, again, this first dimension, the width we could call it. Well, it's x and 4 together, right? So that's like saying it's x plus 4. And then the width, or sorry, the length of it here is 5, and then the x addition meters that they put on. So x plus 5. And all that's got to equal 56 is what we're finding out. Again, kind of see how that sets up. And again, all of these area problems, they just have their own little twist. Each one's a little different. It just takes practice to get better at these. But the more you do, the more you see what they're looking for in terms of how to set up each of the binomials and what the area is. So just keep practicing. You will get better. I promise. It gets better the more you do. Okay, so now again, this problem here, it's not solved for 0, right? So I'm going to have to do some distributing, in this case, I guess, foiling, and then maybe collecting some like terms to get all this stuff together so it's individual terms, and move the 56 over to do that. This time I'm going to do FOIL method, so x times x times 5, 4 times x, and 4 times 5. I'm just going to skip ahead a little bit to help us save some time. That's going to give us 9x squared plus 9x plus 20. And all that equals 56. And then I got to move the 56 over by subtracting it, so it's going to be x squared plus 9x minus 36 equals 0. Now I've got it set up for our factoring. Okay, again, I can't take an x out because there's not an x for every term, and I can't take a number out, so just like a lot of the ones before, I'm going to have x and x, and all equals 0. I've got negative 36 here, so I'm going to have a plus sign and a minus sign. 36 definitely has a bunch of factors, and I got to have ones that have a difference of 9. So I'm going to start listing them here. 1 and 36, 2 and 18, 3 and 12. Oh, right there. I think those two have a difference of 9 for me. So I need to get to positive 9, so plus 12 and minus 3. And so those are my two binomials, x plus 12, x minus 3. So now what values of x will plug in each one of those to make it true? Negative 12 and positive 3. And again, negative 12 won't be my answer, though. So x, that distance we extended the garden by on each side, must be 3 meters. Now, as we're looking at that one then, so if I say that this is 3 meters on each side, okay, 3 meters here and 3 meters here, we got to read the question carefully because it says what are the dimensions of the new garden? X is the increases they talked about. Yep, we did that. So the dimensions of the new garden. Well, this is 3 and 4, so this is 7, and this is 8. So it's a 7 by 8, which is right here. So yep, we must have done it correctly. One more problem I want to go over in this video then is all those ones on the worksheet did rectangles or squares. I want to definitely look at a triangle problem. When we're given the area of a triangle, we've got some dimensions or things we need to find out. They do start to set up very similarly. Just remember that the area of a triangle, if you're doing the formula of that, remember is a couple of different ways you can write it, but you can write it as 1/2 times the base times the height, or you can write it, this is again area of a triangle, T, or you can write it as base times height and all divided by 2. Either of these are the same thing, realize, just formed a little different. And depending on the situation, you can pick which way is easier to set up for what you're doing. So let's take a look at 45 and try to set up like one of these. So it gives us the area of this triangle is 78 square yards. And then it looks like it gives us the height here, which is x, and then it gives us the base, which is x plus 20. So again, using one of our formulas, and I think I'm going to stick more with this one here, and you'll see why in a little bit when it just comes to solving. If I'm going to do the base times the height, well, that's going to be x, and I guess that's the height times the base, which is x plus 20, and all that divided by 2 is going to equal the area, which is 78, okay? Now, again, this isn't set equal to 0, so I'm going to have to do some figuring out here, some distributing and things to get to the point where I can get it to factored form. But one way to take care of this big divide by 2 here is by doing our old inverse operations. It seems kind of crazy, but I can do this. I can multiply the whole left side by 2. I'm going to multiply the whole right side by 2. Because remember, whatever I do to one side, I got to do the other. Well, realize when I do that, all it does on the left side is just cancels out the 2's. Okay, the 2's cancel out. This is like 2 over 1, and it's cross-reducing those. So those go, and I still am just left with all this that I haven't done anything, I haven't touched yet. So I'm going to leave it like that. So realize that dividing by 2 with the triangle part, like, it's not too bad to take care of if you write it out like this, and you can see it. I can cancel out the 2 by just multiplying both sides by 2 like I did there. Okay. And then I'm going to get 156, I believe, over here. Now I can distribute to the left side x squared plus 20x, and I'll move the 156 over to this side as well. So I can kind of do that all in one step. All that equals 0 so far. Okay, so I've got it to the part now where I can look to factor. As I look at this, I've got x squared, 20x, minus 156, all equals 0. I can't factor something out of it, so I'm just going to factor into 2 binomials. So all this equals 0. I'm going to have x and x. I see that this is minus 156, so that's going to be a big help, especially because 156 is a bigger number. So I'm going to have to think a little more with my factors. And again, sometimes it just takes a little bit of figuring out, but still, even numbers like 156 or numbers in the hundreds is nothing that I don't think we can't handle. You just got to kind of take your time and think about all the factors that would work, and even I still list them out to help myself. So 1 and 156, okay? I need factors that are 20 apart, it looks like, because they're plus and minus signs, so 20 apart. 2 and 78, I believe. I'm dividing that by 2. Is this divisible by 3? Yep, because all the digits add up to 21, which is divisible by 3. So, yep, this is divisible by 3 as well. Sorry, not 21, but they all add to 12, which is divisible by 3, yep. So 3 and 52, if I divide that by 3, I get 52. 4, and 4 goes into 15 3 times, then it goes into 36 9 times, so 4 and 39. You can see I'm getting closer. Every one of the differences is getting closer, so I must be closing in on my answer, but I'm not there yet. It's not divisible by 5, but here's a little trick. Notice that it is divisible by 2 and 3, and that's the numbers that make up 6, so it must be divisible by 6 as well, because 2 times 3 is 6. So if it's divisible by both those, it's divisible by 6. 6 goes into 15 2 times, 3 left over, so 36. So it goes in there 6 times, and there's my combination. Those are 20 apart. So it takes a little thinking, a little figuring out. Even I have to list them out, but that is how you can get there. I'm just going to go through one at a time. X plus 26 and x minus 6, that'll give me the positive 20 for the middle term. Yep. So those are my 2 binomials. My solutions for x then are minus 26 and positive 6. Well, again, a lot of these problems here, we get the negative one that doesn't make as much sense, so 6 must be my answer for x. They want me to find the dimensions of the rectangle or triangle. So in this case, it looks like it'll be a 6, and by 26 will be what the total base is. So 6 by 26 for yards.